I'm Will from MBUK and we're here in Bristol at Starling Cycles HQ for a factory tour with a difference. Starling is a small UK bike brand started by one man in a shed and is set to take over the world.
Let's hope so, yeah.
Maybe. With new opportunities coming from inside the bike industry and without, we're going to look at what makes Starling tick. How did it all start for you?
My background, I was an aerospace engineer, so I spent 20 years working in the aerospace industry as a stress engineer, analysing aircraft parts. But as an engineer, I've always made the things that I like doing. I sort of made skateboards as a kid, made remote control cars. And then since university, I've been a really keen mountain biker. So I've always fiddled with my bikes and sort of put little mods on and changed bits of them. We moved into a new house, I had a new shed. I took the opportunity to do a frame building course with Dave Yates, who's kind of an 80s frame building legend. And then once I'd done that frame building course and I made a single speed hardtail, I then set up in my shed to start building bikes. So it was a hobby. So really I started building bike frames as a hobby and people started wanting to buy them. So what was my hobby sort of turned into me selling bikes. You know, after work I was making them and selling them. And then it came to a kind of crunch point at work where I was going to have to start a new project, and I spoke to my boss and said, right, I need a new project, and he said, you don't want to be doing this, do you? You want to be making bikes. So
he sowed the seed in your head?
Pretty much, yeah. So I actually went home that day, looked at the accounting and tried to justify, can I make a job out of building bikes? And I concluded I could. So I think 3 months later, I left that job and just started working full-time in my shed building bikes. So that was the real start of Starling Cycles, full-time job.
How did you then progress forward to the next step?
So the sales were really good. I had like a 6-month lead time. I had enough sales, so I couldn't meet demand. So I actually started looking at what are the options. And I think the first thing I looked at was getting them made in Taiwan. So I actually contacted an agent in Taiwan and we went through the process of getting a batch of 100 frames built. But then I've got 100 frames and my shed isn't very big, so I thought I need a new workshop. So I actually got a new workshop down in St. Werburgh's in Bristol, and that was kind of the move where we went from being me in a shed to having frames in boxes. But I was still making custom frames at the same time. So what we ended up doing was making what we're doing now, the front triangles in the UK, the swing arms we get made in Taiwan, and then we can make the front triangles to order as they come in, and the swing arms are standard sizes between the different models. So it's all, and really that's the business model now, and it's just continued.
And we should say that all your frames are steel, are they?
All the frames are steel, yeah. I think that started because when I was making the frames in the shed, steel is the easiest material to use. But I'd also always ridden steel bikes. I've always had a steel hardtail. I had quite a few steel downhill bikes. But steel's good, it's tough, it's strong. It's not heavy, even though people think it is. It isn't heavy. I'm sure I could do a whole video about that if you want. And,
yeah, I'm sure you could. But essentially, steel is stronger for its weight, so you can use less material.
No, it's actually.
Oh, okay. This is the
lesson.
This is the science.
The number you have is specific strength. It's just strength per weight. So things like carbon and aluminium are stronger for a given weight, but that's for just the pure material. When you start factoring in manufacturing, the design you have to have, different failure modes, fatigue, and all these different things, the gap gets less and less and less. So what I look at all the carbon frames out there is they might be lighter, but they break, and they all break. And people, it's sort of hidden. To me, it's a bit of a hidden thing in the industry that carbon bikes don't break, but they all do. And aluminium bikes are good for a few years, and then they fatigue and crack. So you don't get fatigue in steel. So actually, if you look at a bigger question rather than what is the specific strength, steel is a really, really good material to make bikes out of. It's tough, you can dent it, you can repair it. There's lots of things you can do.
Well, we should probably say, how did you come up with the name Starling?
So Starling, our house backs onto a couple of allotments actually, and the allotments have got these big tall trees in them. And in the trees, the starlings always used to roost. So I used to come out of my shed, which was where I was making the bikes, and look up and there'd be loads of starlings roosting there. So it just seemed obvious they were the birds. And they're quite simple birds like the bikes, but they're also really beautiful. They've got beautiful coloration there, and they're very functional birds. They're good at what they do, aren't they? They're just sort of, so it just sort of all aligned and all made sense. It was
So lots of exciting stuff happening going into the future then.
Yep.
Shall we have a look around at what you do here
Yeah,
and also at the bikes?
Yeah, come on in, follow me.
Let's go. Okay, so where are we now, Joe?
This is our tube storage, so we store all the tubes for the bikes here. So do you want me to show you a tube and take it through how we turn it into a frame?
Class, let's have a look.
So this is a Tubes and Reynolds, this is a down tube, 853 down tube. Take out the box, we'll just get one. We've already QC'd it, so the first step is actually to check it's all good. So you can see we've marked the butts on, we've checked the butt lengths, we just check it for roundness and overall check it's okay really first.
Yeah. So where are we going next? We've got our tube, it's QC'd.
Yeah, so it's all ready to go. We'll take it into the dirty room where we cut it and shape it to go into the frame.
Right, so we check the butt thickness and we're off to the dirty room.
So this is the raw down tube, and we want to make it to this shape. So we put a flat cut on the bottom which joins to wheels holding this bit. This is the bottom bracket, main pivot, and it's got a connection to the seat tube. And you can see the down tube welds on there like that. You'll see in a minute when we do the full frame. Back to you. You're good helper, Will.
Cheers.
And then
don't worry, I won't be welding any frames. It's fine.
And then this is the connection. We cut it to the shape of the head tube. So you can see it's got a mitre on it, the shape of the head tube. So the flat cut here, we just put on with a simple chop saw, and we've modified it a bit to allow us to cut it. That's quite simple. This is kind of the exciting machine. This is called a tube notcher, and this puts in this curved shape. And what we essentially do, and we'll have a look, if you zoom in here, it's basically a big belt sander with a curved mandrelin, or a round mandrelin. And if we have a look in this cupboard, at the top, you can see all the different mandrels for the different sized tubes. So when it's finished on that, we just take it onto this and clean it up quickly. So we take it off that and we put it in this. This is a very special machine called the disco roller, and it's the disco roller because it does that. But basically this is just a jig that holds the tube, and we get a bit of sandpaper and we just clean up the outside and clean up the inside of the tubes.
I'm qualified to operate this.
So we do that process, the cutting, the tidying up the ends, the cleaning up with the cloth, cleaning up inside of the little machine to all the tubes that then can go into the jig. So here we have the down tube that we saw getting cut to space, so that cut to size, so that just drops in there. Oh yeah, we've already got the head tube fitted in.
Nice.
Just get that clamp. And then the top tube, hopefully it's the right size top tube, just drops in like so. Okay, so there you go. It starts looking a bit like a bicycle frame. We just put a tack, which is like a small weld, which holds it in place, and then we do the full welds out of the jig. It's worth saying here about brazing. We braze our frames rather than TIG weld our frames. So the difference is a TIG weld is where you use a steel filler and you basically fuse the steel into two different steel tubes. Brazing, you use a brass filler, and it's more like a glue. It's like a big blob of soft melted glue into the place. And the brazing is a bigger joint, there's more material there, and it's a softer material. So I personally, as a stress engineer, and that's my old job, I think brazing is a better way to join joints. It's more damage tolerant, it gives enough strength, you put less heat into the tube, which is better for keeping the tube strong. But there are some places where TIG, I think, is better than brazing. So on our bottom bracket to this machining, this casting here, we use a TIG joint because this is quite thick, this is quite thick, and it just makes more sense to use TIG in that location.
So what have we got here, Joe? Is this... I feel like I'm in Star Wars.
It's not a pretend lightsaber. That's a big metal bar, that's probably called. That is one of the 2 big metal bars. And
that's the technical term.
That is the technical term. It's just a big metal bar. We use that to align the frame. So when you weld it together, as much as the jig is straight and everything's cut straight, it still moves a little bit as you weld it. So at lots of stages, we do 4 alignment steps on our frames as we build them. And this is the table we use it. So this is a steel table, it's perfectly flat. Got some fixtures here. So I'll show you putting this frame in. Wind that in, yeah. Keep winding, wind. Really tight.
Oh, really tight.
That's it, okay. So now, we put that little puck in there and that sits on that block. So we know that this is perfectly parallel to the table. Yeah. We know that this has all been checked to square before. So all we need to check is that this seat tube is perfectly parallel to that line there.
Right.
So we use this thing, which is a height gauge. There's a little bit of a gap there. So that means that needs to go down that way.
Right.
So that's where we shove in big metal bar and give it a tweak.
Ah, I got it. Yeah, this is so cool. Like, there's far more steps than I expected involved in making a steel front triangle.
Yeah.
So are we finished?
Not yet. This is tacked together. We now to weld it and put on the various fittings, head tube gussets, cable guides, a few other things. So I'll show you how we do that now.
Let's go.
So yeah, here's one we made earlier. So this is pretty much a finished frame. We've welded up all the joints of the head tube, seat tube, bottom bracket, main pivot area. We've finished off welding up or brazing up, I should say, the shock mount. We've put on this head tube gusset. So Starling bikes all have this plate head tube gusset, nice long legs to lead the load in, nice little bird detail for a bit of prettiness. And then that's pretty much it finished. It's some weird animal.
So we're back in the dirty room and we need to ream some holes.
Yeah, okay. So the head tube, as we weld it, it essentially distorts out of shape. So we have to put in a reamer which goes in the top and bottom, which cuts it to the right size for the headset. And it also faces these surfaces here so they're nice and flat. The seat tube, we now put an aluminium shim in here. With steel frames, you get a problem where the aluminium seat posts galvanically corrode into the steel. So there's a difference in the electric potential of the different metals, which means they essentially corrode together. So we now ream this out and then insert a metal shim, an aluminium shim, which stops that happening. Okay. And then ream the shim out afterwards. So that needs to be done. The bottom bracket here, just as you've welded it, it's threaded now, but the threads get a bit dirty, so we have to put in a tap to clean them out. And then the main pivot here, again, distorts a tiny little bit in welding, so we actually just ream through there.
And what happens if you don't ream and face the headset and the pivot tube?
Then the bits you're putting in won't fit in properly. Or if you didn't ream the head tube, you'd probably be able to whack in a headset, but it would just be distorted and it would wear very quickly.
So is it finished now, Joe?
It's finished now. We've done everything we need to do to it. It now needs to go to the powder coaters. So that's off site, but I can show you some painted frames upstairs.
Oh yes, please.
Okay, let's go. So yeah, here's a whole batch come back from the powder coaters. Some of them have had the swing arms assembled on, shocks put on, stickers, we put decals on, but really that's it, yeah, wide range of colours.
Do you know how many colours you offer? I
think we do 8 kind of non-metallic colours and then we do 4 metallic colours.
Well, so it's lunch break time at Starling Cycles and we're sessioning the mini ramp because every production facility needs a mini ramp, right? Oh my God, it is real. When you fake it, you realise how steep it is. As you can see, we've left the workshop and Joe's going to show me how the Starlings perform out on the trail.
Okay.
Send it. So there you have it, a look inside a small British bike brand heading for big things. Thanks to you, Joe, and the team for showing us around.
No, it's been great having you. Thank you.
If you enjoyed this video, don't forget to give it a like and subscribe for more videos about your favourite bike brands.